we're going to use the definition of the derivative to differentiate f of x equal to the square root of sine of x. Now to do it, we're going to need the following two results. The first one is the trig identity. Sine of alpha minus sine of beta is equal to 2 times cosine of alpha plus beta over 2 times sine of alpha minus beta over 2. And the second result we're going to need is the limit y goes to 0 of sine y over y equals 1. So let's begin. First, recall the definition of the derivative. F prime of x is defined as the limit as h goes to 0 f of x plus h minus f of x divided by h. Now in our case, that limit is going to be h goes to 0. F of x plus h is the square root of the sine of x plus h. F of x is square root of sine of x, and this is divided by h. Now if we plug in 0 for h now, we get 0 over 0. So we have to do something to get rid of that indeterminate form 0 over 0, express it in a different way. The first step we're going to do is multiply both numerator and denominator by the conjugate of the numerator. So this will look like this. Here's our original limit. It is sine of x plus h under the radical minus sine of x under the radical divided by h, and we'll multiply this by square root of sine of x plus h plus the square root of sine of x divided by the very same thing, square root of sine of x plus h plus the square root of sine of x. So let's see what this becomes. The numerator, by multiplying the numerator by its conjugate, will eliminate radicals. So we just have limit h goes to 0 sine of x plus h minus sine of x in the numerator, while the denominator has h times the square root of sine of x plus h plus square root of sine of x. Now we can use the first result. If we call x plus h alpha and x beta, we have precisely sine of alpha minus sine of beta, so we can express it using the trigonometric identity, which I called result number 1, and this becomes the limit as h goes to 0 2 times cosine of alpha x plus h plus beta, which is x, divided by 2 times the sine of alpha, that's x plus h, minus beta, that's x, divided by 2, and this is divided by, the denominator didn't change, h times the square root of sine of x plus h plus the square root of the sine of x. Now we're going to split this up into two limits. First, note that, let me rewrite this, simplify what's inside sine and cosine in the numerator. So this is the limit as h goes to 0. In the numerator we have 2 times cosine of 2x plus h divided by 2 times the sine. X is canceled inside the sine, so this is h over 2 divided by h times the square root of sine of x plus h plus the square root of the sine of x. Now let's rewrite this as two limits. Okay, so the first limit is going to be the limit h goes to 0. We'll take 2 sine of h over 2 divided by h times the limit as h goes to 0 cosine of 2x plus h over 2, and that is divided by the square root of sine of x plus h plus the square root of the sine of x. Now let's look at the first limit. In the first limit we have h over 2 inside the sine. We have h in the denominator. So I'm going to take this h in the denominator multiplied by 2 over 2. Didn't change anything. You can see that this 2 will cancel with the 2 here in the numerator, and that will leave us with the following. We get the limit as h approaches 0, sine of h over 2 divided by h over 2 times the limit h approaches 0, cosine of 2x plus h over 2 divided by square root sine x plus h plus square root of sine x. Now, in the first limit, let's make the following substitution. We're just going to let y equal to h over 2. Note that as h goes to 0, y also goes to 0. And now, for almost the final step of this problem, we rewrite the first limit as y approaches 0, sine y over y, that's result number 2, that limit is 1, times the second limit as h goes to 0, cosine of 2x plus h divided by 2 divided by the square root of sine of x plus h plus the square root of sine of x. So now let's take the limits. The first limit is 1 times the second limit as h goes to 0. We have cosine of 2x over 2, and in the denominator as h goes to 0 we have square root sine x plus the square root of sine x. And when we simplify this, this becomes cosine of x divided by 2 times the square root of sine of x, which is the final answer. Let's summarize this. If f of x is equal to the square root of sine x, we just showed by definition of the derivative, f prime of x equals to cosine of x divided by 2 times the square root of sine of x. For more videos,